Number 5, the rate of the reaction doubles when the temperature is increased from 20 degrees Celsius to 35. We're going to calculate EA for this reaction. All right, so this comes to mind, right? We have a rate, we have the rate doubles, all right? So we have rates and temperature and EA. So to me, all right, that is the Arrhenius equation, all right? And I've got two rates, and I have two temperatures, so that's probably going to be the natural log of K1 divided by K2 equals EA over R 1 over T1 minus 1 over hold on, I gotta make sure I did that right. I apologize. I do sometimes flip up T1 and T2. Yeah, I did. It's T2 and T1. I flipped that on you. This is why you use your formula sheet. All right, now, the hard part. I would write down K1, T1, K2, T2. We know what R is. R is the 8.3145 joules per mole Kelvin, and EA is the question. And so the reaction rate doubles, right? So I would do K1 is 1 and 20 degrees Celsius. K2 is 2 and 35 degrees Celsius. All right, now we have to go to Kelvin, so we have to add, right? Remember, you add 273, right? So 35 would be 308, and 20, I'm back to green, right? 273 would be 293. And we got to keep K1 and T1 together and K2 and T2 together. So K1 and T1 are there. I'll highlight. I like highlighting better. K1 and T1. I use purple. K2 and T2. All right, and we're solving for EA. Okay. So natural log equals 8.3145 joules per mole Kelvin. All right, this EA is easy. It goes there. Now, K1 is in green. I got a 1, and T1 is in green. I got 293. And then I use purple. I got K2 is in 2, and T2 is 308. All right, that's the hard part right there. Now it's just a little bit of algebra. All right, and so again, how you do this, the algebra, whether you do the natural log and then you move over and then multiply it, right? Okay, it doesn't necessarily matter to me how you do this, all right? But if you were just to do it all, natural log of 1/2, right, times 1 over 308 Kelvin, right, minus 1, no, I'm sorry, that's on the bottom, isn't it? That's on the bottom. Times R, 8.3145 joules per mole Kelvin, divided by 1 over 308K minus 1 over 293K, right, equals REA. All right, and so if we do this, I get the natural log of 1/2 times 8.3145 divided by 1 divided by 308 minus 1 divided by 293. I get 34,672.78099982. All right, great. Okay, I have, how many sig figs do we have? We have, technically we only have one. All right, according to this. Technically we have one. All right, but when we add 273, I get 2. So I have to assume 20 is 2 sig figs. Right? If I assume 20 is 2 sig figs, I actually get 3 in my problem. If it's only 1 sig fig, I only get 2 in the problem. All right, that's very important. And so EA is 34,700 joules per mole, or 34.7 kilojoules per mole. That's if I get the 3 sig figs. If I only get the 2, it's 35 kilojoules per mole. Right? So now, hopefully, we don't have any confusion, right? Any ambiguity, anything ambiguous here. Ambiguity, there's the word I was looking for. Any ambiguity here, right, with the 20. All right? But that's how you would do the Arrhenius equation with 2 points.